All right, J J Thompson. J J Thompson is our next old dead guy. J J Thompson, from all of the books that I've read, was apparently a highly personable guy. The kind of guy that everybody likes to hang around. A little bit rotund, kind of a round guy. But he was a guy that everybody wanted to hang about, the life of the party, generally an enjoyable guy to be around. He's a university professor in much the same way that we have professors today. So the idea of a university has really grown and changed since Dalton's time. And Thompson is right there in the heat of it. This is 1897, right around 1900, the turn of the century, and things are just popping. This is the time period when electricity really, the people who have done the science of electricity are starting to turn that science into inventions. We're having wars between Edison and Tesla over whether the world will be electrified with AC current or DC current. People are inventing things that are using electricity in order to advance our lives. And Thompson is right there in it. And he's taking these inventions and he's using them in new and different ways to learn about the world around him. One of these inventions, an invention that affects your life still today, even though you might not have one in your house, is something called the cathode ray tube. The cathode ray tube was an invention that was the foundation for television. Alright, it was the foundation for television. So without the invention of the cathode ray tube, no TV, no video games, no internet. Okay? So you need to have this invention of the cathode ray tube. And J J Thompson has one. And he's messing with it. He wants to figure out what it is, what makes it work, why does it do what it does, how does this thing, why is it, what is it, how does it do what it does, it's just this crazy little thing. What it is, it's a tube that is, let's call it a vacuum tube, which means there's no air in it. But there is a little bit of metal, and you can run an electric current through it, because everything was all new and cool about electricity.
Wait, what is this thing called?
A cathode ray tube.
Why is it called cathode?
Because these things are called cathodes, and then it's a tube, and then when you run electricity through it, there's a ray. And he was really curious about this ray. He was really curious about this ray. So, it's like, what is it? He puts a magnet next to it. And it bends towards the magnet. So what does that tell him? If the positive end of the magnet bends towards the magnet, what does it tell him?
That the ray is negative.
The ray is negative. So he learned that whatever that ray is, it's negative. Alright? Then, he puts a little obstacle in there. And the stuff moves around the obstacle like particles, but not like a gas. You know how a gas would like fill in behind it? But it moves like particles, like there's a shadow. So he's like, whatever it is, it's a particle. And it's moving. And it's negative. And where's it coming from? It's got to be coming from this chunk of metal here on the end. Well, that metal thing is made out of atoms. Because everything's made out of atoms. So somehow, he's getting atoms, or pieces of atoms, off of this chunk of metal. It's like, well, if this is a piece of an atom, that means that atoms aren't indivisible. I'm getting a piece. And this piece is negative. But I know that the whole atom doesn't have any charge. So he can logic out that there's got to be something else. What is the something else that he has to logic out? If there's something negative, what else does there have to be in order for everything to be Neutral.
Positive?
Positive. So he's found proof of something negative. He has not found proof of anything positive. He's logicked out that there has to be something positive. Does that make sense? Do you see how you could do that? He has no evidence of anything positive. He only has evidence of the negative. But he uses logic in order to figure out there's got to be a positive thing. So he takes these negative things and he calls them corpuscles. J J Thompson does not get to name the electrons. Apparently nobody likes the name because now we call it electron. Alright? And he has these negatively charged particles and he knows there's something positive, so he says, well, there's got these little negative things inside a positive, like, doughy structure. So he decides to make a model of the atom, and he forms his model of the atom based after his favorite dessert. He's in Britain. Britain is not known for their cuisine.
Fish and chips.
Fish and chips don't look like an atom.
Well, how did he know that? He did this next to sleep.
Well, think about it. What can you think of that has little things in it that you can get out, but the things that you can get out are different from what's left in there?
Well, I think of an eclairs.
Okay, because of like the cream you can get out. The catch is that can you think of something that has like more like particles? Something more particly? Fruitcake is perfect. Fruitcake is perfect. In fact, fruitcake is almost exactly like J J Thompson's favorite dessert. J J Thompson's favorite dessert is something called plum pudding.
Oh.
It is a bready thing that has little tiny candied fruits in it. It is almost exactly like fruitcake. Now, the average 7th grader really doesn't know much about plum pudding. But they know plenty about chocolate chip ice cream.
Oh, yeah.
So here are 3 visual models. Let me erase this over here. Of J J Thompson's model of the atom. Excuse me. This is J J Thompson's model. You can see they have little tiny things in here. And he thought that this stuff in the middle of the stuff all the way around, all that was positive. He didn't know much about the positive stuff, but he knew that it had to be there. He named it after his favorite dessert, plum pudding. A junior high American might be more familiar with the blueberry muffin.